Okay, I'm back. Lesson 3.15, continuing with our word problems. So in the first part of this lesson, I went over type 1 and type 2 word problems where, type 1 was if we were given the initial value and the slope. Type 2 was where we worked with a standard form equation. So now we're going to look at a third type of problem we might come across. So we might see this problem. So we're going to use the strategies I show you when the problem gives a sample point and the rate of change. So when the problem gives a sample point right? So x1 comma y1 and rate of change. Which is our m. Okay? So again, right, remember type 1, we use if we're given the rate of change in the initial value. Okay? Now type 3 is different. We're given a point, but that point is not the initial value. It's just some sample point and the rate of change. Okay. So let's just jump into the first problem. And again, first we're going to create the equation and then we're going to solve it. So let's highlight some important information. So at Eagle Bay, it costs $12 per hour to rent a canoe. Nate and his friends rented a canoe for 4 hours and paid $68. Write an equation and solve a linear equation to find the cost to rent the canoe for 7 hours. Okay. So first we're going to use the highlighted information to build our equation. All right. So again, we're going to say, again, we want to define our x and y. And it's important, unlike in the standard form, right? So x is our independent variable and y is our dependent variable. So again, we're talking about the cost of a canoe. So cost is our dependent. And what affects the cost? Well, the number of hours, right? So the number of hours. Okay. And we're also given the rate of change. Hopefully you notice that. Right? M is $12 per hour. And we're also given a sample point. Okay? We're told that, 4 hours cost $68. Okay? So what that means is we're going to put that information into an ordered pair. Remember, it's x comma y. So it's number of hours, which is 4, comma, cost, 68. Okay? So here is our sample point. Okay? All right. So what we're still building the equation, okay? So what we're going to do is we're going to start off with a partial equation. So we have y is equal to 12 times x plus, well, we don't have b this time, right? We don't have b. So what that means is we still need to solve for b. Okay, so what we're going to do is we're going to plug in our points. So we're going to substitute the point 4, 68, and we're going to use that to solve for b. Okay, So I'm going to run out of room. They don't give you much room here, but that's fine. I'll just resize it later. So, okay. So $68 is the cost, is my Y. 12 is my rate of change. 4 hours plus B, okay? And then we're going to use that to solve for B. So that gives me an equation of 68 is equal to 48 plus B. And then finally, that's going to give us a B equal to 20. Okay? So therefore, our equation is Y is equal to 12x plus 20. All right? So that is our equation. We had to do a little bit more work to get it this time. Okay? To do a little bit more work to get it. So now we're going to move on to the second part of the question. Okay, write and solve a linear equation to find the cost to rent the canoe for 7 hours. Okay, now are they giving us X or Y? Well, they're saying 7 hours. So let X, which is the number of hours, equal 7, and then simply solve for the cost, which is Y. Okay, so we have Y is equal to 12 times 7 plus 20. And that's going to give us, well, that is 84 plus 20, which gives us $104. So therefore, to rent the canoe, canoe for 7 hours, it will cost $104. Okay. All right. So there we go. Oh, sorry. Okay. All right. So there we go. To rent the canoe for 7 hours, it will cost. Oh my goodness. It will cost $104. Sorry. There we go. All right. Question 10. A construction company charges $18 per hour for debris removal. Okay, debris removal means they're getting rid of all the garbage, right? They're cleaning things up. Plus a one-time fee for the use of the trash dumpster. Okay? So they're telling us there is an initial fee. They're just not telling us what it is. Okay? So they are giving us the sample point though, okay? It says the total fee for 8 hours of service was $212. Write and solve a linear equation to find the one-time fee for the trash dumpster. So it's asking us to find the initial value actually. Okay, so let's go ahead and do that. So I'm going to create my equation and I'm going to figure out what my one-time fee is. Okay, so X and Y, we have to identify those first, right? Okay, so X is our independent, Y is our dependent. And again, we're talking about the cost or the total fee. Total fee, I guess I'll use. Total fee. And that's in dollars, right? Dollars. And then X, well, what affects the price? Well, it seems to be the number of hours. Okay. Now, what else are we given? Well, we're given the rate of change, right? M is $18 per hour. So the price goes up $18 for every additional hour. Okay. B, we don't know. Okay, we don't know what B is. okay? But we do have a sample point, okay? So our sample point, well, we're told that for 8 hours of service, remember X comma Y, it cost $219. So that is our sample point, 8 comma 219. Okay, so now we're going to create our equation. So I'm going to say I have y is equal to 18x plus b. I don't know b, so I have to solve for it. So I'm going to substitute the point 8 comma 219, and I'm going to solve for b. Okay, so 219 is my cost. They worked 8 hours. Okay, so now I can rearrange and solve for b. So 219 is equal to 8 times 18. I don't know what that is. 144 plus b, and that is going to give us a b equal to, well, remember, we've got to pick that up and move it over. So 219 minus 144, and that gives us a b equal to 75. Okay, so that means my equation is y is equal to 18x plus 75. Okay. Okay, and that's actually all of this question is asking us to do. So it's asking us to find the one-time fee for the trash dumpster. Well, we did that when we solved for b. So we're done this problem. So therefore, the one-time fee and I'll write in brackets initial value is $75. All right, there we go. Okay, so moving on. Question 11. A company offers premium cable for $39.95 plus a one-time setup fee. That one-time setup fee should ring bells and make you pay attention because it means initial value. Okay. The total cost for setup in 6 months of service is $264.75. Write and solve a linear equation to find the total cost for 2 years of service. Okay. So again, first we have to create an equation. We're going to use this information to create it. Okay, and then we'll move on to the second part. So again, let's define x and y. Okay, well, again, we're talking about cost. We're talking about price, right? So again, our dependent is total cost of the cable, right? Okay. Plus, oh, sorry, got distracted. And x is the number of months, I guess. Number of months. You know what? I just realized there's a typo in this problem. And it should be that it says here that this is per month. Okay, there's a typo in here for sure. So a company offers premium cable for $39.95 per month plus a one-time setup fee. Okay, so yeah, without that it would have been confusing, I think. Okay, so what about our rate of change? Well, our rate of change is $39.95 per month. Okay, we don't know what B is, right? B is a mystery to us. Okay, but we do have a sample point, right? We have a sample point. We know that for 6 months of service, it cost $264.70. Okay, so that is our sample point. Okay, so we have our partial equation. Y is equal to 39.95 times x plus b. We're going to substitute our point, 6,264.70, and solve for b. Okay, so 264.70 is my y. 6 is my x, and I'm solving for b. Okay. So as I simplify, I get 264.70 is equal to 239.70 plus b. And then we're going to rearrange and solve for b. B is equal to $25. Okay, so that means our equation is y is equal to 39.95 times x plus the one-time $25 fee. Okay, so now let's solve this equation. Okay, or move on to the second part. So it says write and solve a linear equation to find the total cost for 2 years of service. Okay, what are they giving us? Are they giving us X or are they giving us Y? Well, they're most definitely not giving us Y, right, which is total cost. And technically, they are giving us the number of months, okay? It's just written in a different form. It says 2 years, okay? X does not equal 2, okay? Because that would mean 2 months. Here we mean 2 years. So knowing that there's 12 months in every year, right? That would mean that our x, for 2 years, we're going to let x equal 24, right? 24 is 2 months, right? I'll just write that. 24 months equals 2 years. Okay? And then, so once we have that, we're going to solve, and we just simply solve for y, which is the cost. Okay? So y is equal to 39.95 times 24 months plus $25. Okay? And once we calculate 35.95 times 24 plus 25, we're going to get a total of $983.80, I believe. Yeah. Okay. So now we just have to add our therefore statement. Okay. So therefore, 2 years of service will cost $983.80. And notice how in my concluding statement, I include the unit, dollars, right? I include the unit in my concluding statement. Okay, good. Question 12. A home security company provides security systems for $5 per week, plus an installation fee. So again, we're not told what that installation fee is. The total fee for 12 months of service is $210. Write and solve a linear equation to find the cost of the installation fee. This is another question that's asking us to solve for our initial value, right? Our initial value. So let's get started. Let's define our variables. So x and y. So again, y is cost, the cost of the security system, okay? Again, it's costs. We seem to be doing a lot of money in these problems. And X is, well, what affects the cost? The number of weeks, okay? Number of weeks. Okay, and then M is also provided, right? We know that the rate of change is $5 per week. And we don't know what B is, right? B is a mystery. But we do have a sample point. And our sample point is that we know that for 12 weeks of service, it costs $210. So that's our X1, Y1. That's our sample point. Okay, so create our partial equation. Y is equal to 5x plus b. Substitute in the data. So I should write that. So plus b. So we're going to substitute 12, 210 into our equation and solve for b. Okay, so 210 is my y, 12 is my x. Okay, I get 210 is equal to 60 plus b, and then that's going to give me a b equal to 150. Okay, so that means my equation is y is equal to 5x plus $150. Okay, well, the installation fee, right, that's my initial value. So therefore, the installation fee is $150. Okay? All right, last type of problem solving. So in this type of problem, when you're reading the question, you would not be given slope. And in fact, you would only be given 2 sample points. Okay? 2 sample points. So we're going to use this strategy when the problem gives us 2 sample points. Right? So when we have our x1, y1, and when we're also given a second point, so x2, y2. Okay? All right. So to surf the internet for 15 minutes at the airport, it cost $4.05. For 40 minutes, it cost $5.80. Write and solve a linear equation to find the cost for surfing the web for 1 hour. Okay. So again, let's define our x and y. Okay. So we have cost and we have the number of minutes. So number of minutes is our independent and cost is our dependent. Okay. And this is important that we define this because when we write our sample points, they need to be written in the correct order, x, y. Okay. So we have 2 sample points. Our first one is we have 15 minutes cost $4.05. So that's point 1. And we have the second data set sample point where we have 40 minutes cost $5.80. Okay, so those are our 2 sample points. And we have to come up with an equation and then eventually use that equation to solve. Okay, so if we're given 2 sample sets, again, to come up with an equation, we need to solve rate of change and we need to find y-intercept. So our first step when we're creating this is to find our slope. Find m. Okay, so m is equal to y2 minus y1 over x2 minus x1. So use your data points. So 580 minus 405 divided by 40 minus 15. This is going to give us, hold on, 5.8 minus 4.05. So we get a 1.75 and over $25. Okay, so now what we have to do, oh, sorry, we're not quite done. Actually, I ran out of space. I'm going to try to take up less space. Okay, so that's going to give us an M equal to, so 1.75 divided by 25 equals a small amount. So 7 cents per minute. Okay, so there we have our M, but we need our B now. Okay, so again, we have to find B. So to find y-intercept or initial value, right? Okay, so we have our partial equation. Y is equal to 0.07 times x plus b. Now what we're going to do is we're going to substitute one of the points. It doesn't matter which point. I promise you, regardless of which point, you will get the same answer for B. If you don't believe me, try it yourself. Okay, so I'm going to substitute the point 15, 405, 4.05, sorry. Okay, so y is 4.05 times x, which is 15. Okay, so we get, now what is 7 cents times 15? That gives us 1.05. And that's going to give us B equal to 3. Okay. So that means our final equation, or our completed equation, is equal to y equals 0.07 times x plus $3. Okay, so it costs 7 cents per minute plus an initial charge of $3. Okay, so now let's move on to the second part of the problem where it's actually asking us to solve this problem. Okay, so write and solve a linear equation to find the cost for surfing the web for 1 hour. Okay, so are they giving us X or are they giving us Y? They're definitely not giving us costs, they're giving us time. Okay, but should I set X equal to 1? Well, I should definitely not, okay? Because X is the number of minutes, okay? So 1 hour is equal to 60 minutes. So I'm going to let X equal 60, okay? And that's because 60 minutes equals 1 hour. Hopefully you guys knew that, right? Okay, so we're going to let x equal 60, and we're going to solve for the cost, which is y. Solve for y, okay? So we get y is equal to 0.07, 0.07 times 60 plus that $3. Okay. So 7 cents times 60 gives us $4.20 plus our $3. So we get a total cost of $7.20. Okay, so therefore, to surf the web for 1 hour, it costs $7.20. Remember, put the unit in your concluding statement. Okay, good. So again, the following problems are identical. Okay, so we're going to be given problems where we have two data points, two sample points. Okay, so let's see. Water boils at 100 degrees Celsius or 212 degrees Fahrenheit. Water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. Okay. If the weather forecaster says it will be 25 degrees Celsius, write and solve a linear equation to find what Fahrenheit temperature is. Okay. So our two data points, right, are the temperatures that water boil and the temperatures that water freezes. Okay. So in this case, our X and our Y, they have to be either temperature in Celsius, and then Y is going to be temperature in Fahrenheit. Okay, because that gives us our two sample sets. Remember, X comma Y. So 100 comma 212, and then our next data point is 0 comma 32. Okay. So again, independent, dependent, if you guys have these swapped, in this scenario, it doesn't really matter. And I know that's confusing because I've said it matters in most cases, but there are some scenarios where we have two variables and it's really hard to figure out which one is the independent or which one is the dependent, because they're so interconnected. So in this case, if you swap them, that's okay. It won't affect your final answer. It'll affect the equation you come up with, but it won't affect your final answer. Okay, so let's find the equation. So again, step 1 is to find the slope. So find that slope using our two data points. So m is equal to y2 minus y1. So I'll put 32 minus 212 over 0 minus 100. Okay, so 32 minus 212, we get negative 180 over negative 100, and that's going to give us 1.8. Okay, 1.8. Okay, so that means that we have a partial equation. So 2, now we have to find our y-intercept. Find y-intercept, or initial value. Initial intercept. Okay, so we have y is equal to 1.8 times x plus some b. Okay, now I'm going to sub in one of the 2 points. It really doesn't matter which one. You know what? I might pick the one with numbers that I think are personally easier. So I'm going to pick that one. Okay, so if I put in, so I'm going to substitute the point 0 comma 32, and that's going to give me b. We'll see. Okay, so if 32 is y, 0 is x, well, anything multiplied by 0 better be 0. Okay, so that actually gives us b is equal to 32. And we should have actually been able to realize that right away, that this is our y-intercept. Okay, because the y-intercept always has 0 for x. Okay, so that means my equation, let me just write that out. Therefore, my equation is going to be y is equal to 1.8x plus 32. Okay, so there we go. That's my equation. Let's move on to the second part. So write and solve a linear equation to find what Fahrenheit temperature it is if the forecast says 25 degrees Celsius. Okay, so they're giving us the temperature in Celsius, and they want us to find it in Fahrenheit. So what I'm going to do, since x is Celsius, I'm going to let x equal 25, and I'm going to simply solve for y. Okay, so y is equal to 1.8 times 25 degrees plus 32. So 1.8 times 25 plus 32 is going to give us 77. So therefore, 25 degrees Celsius is equivalent to 77 degrees Fahrenheit. Okay? And question 15. The value of a car decreases at a constant rate. After 3 years, the value of the car is 15,000. After 2 more years, the value of the car is 11,000. Write and solve a linear equation to find the value of the car after 8 years. So x and y. So y is clearly the value of the car. Value of car. Okay. Now what affects the value of the car? Well, it says that it depreciates and we're looking at, so after 2 years and then after 8 years, right? Or sorry, 3 years, after 3 years and then after 2 more years. So x is going to be the number of years. Okay. Now what are our 2 data points? Okay. Remember, write them in the correct order, x, comma, y. So it says for 3 years, the car's value is 15,000. Okay. After 2 more years, the car is worth 11,000. Okay. The way it's worded, I hope you're paying attention, because 2 more means that our x value is actually 5, right? So after 2 more years, now the value is 11,000. Okay, so these are our 2 sample points. So now we go ahead and we solve for slope. Okay, so m is equal to 11,000 minus 15,000 over 5 minus 3. Now, the car's value is going down. So our rate of change, our slope, it better be negative, okay? Because the value is decreasing. It's not increasing. So let's see, 11,000 minus 15,000. That's going to give us negative 4,000 over 2, which gives us a rate of change of negative $2,000. Or sorry, negative 2,000. Okay. So that means the car's value decreases by $2,000 every year. All right, so let's go ahead and use that to find our y-intercept, our initial value. So find y-intercept, or find your b. Okay, so we have our partial equation, y is equal to negative 2,000 times x plus b. I'm going to put in either one of the points, doesn't matter. Okay, I'll put in the first point. So I'm going to substitute the point 3, 15,000, and I'm going to solve for b. Okay, so we get 15,000 as my y. I get negative 2,000 times 3 plus B. So our B becomes equal to 15,000 plus 6,000. So our initial value becomes $21,000. Okay, so this means that my final equation will be y is equal to negative 2,000 times x plus 21,000. Okay, there's my initial value of the car is 21,000. Okay, and I want to find the value of the car after 8 years. Okay, so they're giving us x and they want us to find y. So what we're going to do is we're going to let x equal 8 because we want to know the value after 8 years. Okay, so we get negative 2,000 times 8 plus 21,000. And that's going to give us, let me just see here. So, 21,000 minus 16,000. We're going to get $5,000. Okay. So after 8 years, okay, the value of the car is $5,000. Okay. And that's it. All right. So last example I'm going to go through. Customers of a satellite dish company must pay for installation of the dish and a monthly fee for service. After 6 months, Ryan had paid $594. After 11 months, he had paid $989. Write and solve a linear equation to find the cost for installation. So again, this question, it wants us to find the initial value, okay? So again, let's define our variables, x and y. Okay, so again, y is total cost. X is the number of months. Okay, so our data points are 6,594 and 11,989. Those are our two data points. Okay, so now we're going to determine the slope. So we get m is equal to y2 minus y1. So 989 minus 594 divided by x2 minus x1. So 11 minus 6. 989 minus 594. We're going to get a nice 395 over 5. And that gives us 79. So our rate of change is 79. So now 2, we're going to find our y-intercept, our b value, or our initial fee. So again, I have my partial equation, and I sub one of the two data points in. It doesn't matter which one I choose, okay? So I'm going to I'll sub in the second one this time. So substitute 11,989 and solve for b. Okay, so 989 is my y. 79 times 11 plus B. So B is equal to 989 minus, what's 79 times 11? 79 times 11 minus 869 is equal to B. And that's going to give us a B. So 989 minus. That gives us an initial fee of 120. So therefore, right, my equation is y is equal to 79 times x plus 120. Okay? And my installation fee, right, that's my initial value. So therefore, the cost for installation is $120. Okay? So wow, we did a lot of questions, okay? So now I have these 4 questions, okay? You have to determine what strategy, what type of problem is it, and you need to solve these 4. I want full solutions of you guys showing all of your work. Okay, so these 4 problems are going to be the assignment for this week, and you are going to submit your solutions to these 4 problems. Okay, all right, excellent.